Okay, guys, so we continue with our math review, and now we are going to talk about counting methods. So this topic is more commonly evaluated in GRE and GMAT than in the SATs or the ACT, but still pay attention to this one. However, you want to pay closer attention if you're aiming for one of those two exams, GRE or GMAT. So counting methods, what are those? Well, there are a couple of tricks that help us to count, especially how many total possibilities we have of selecting something. So let's go step by step. First big scenario is whenever we need to come up with arrangements. Meaning, at some point the question may ask us to find how many different arrangements can I have? How many different arrangements can I have? So meaning you have a set of elements and in how many different ways you can organize them, okay? In how many different ways you will be able to organize them. So for example, let's say that, well, you have here your bookshelf, okay? And in your bookshelf you have some books, okay? So let's say that I have here a book, here I'm gonna have another book, and let's go with 5 books maybe, 3, 4, and 5 books, okay? So this book is about, I don't know, mathematics. This one is about history. This one has to do about your, I don't know, TOEFL exam, your GRE exam, and your SATs exam. Okay. So this is one possible way of me organizing my books in my shelf. First the one in math, then history, then TOEFL, then GRE, then SATs. But whenever I take one out of the shelf and then I put it back, maybe the organization changes because eventually I can organize these 5 books and they can have an organization like this one, right? Like I took one and let's say I took the TOEFL book here and then I put it at the end, so the books will be in this order, right? History and math. Or eventually they can be organized as GRE and then the math and then the SATs and then TOEFL and then the one on history and etc. There are many different ways in how I can organize the books. How can I find the total? Okay, number of possible arrangements that I can have. What we will do here is gonna be simply, whenever you want to find that, is the total number of elements factorial. Remember that this little guy is factorial. Let's have here a quick review of what factorial is, okay, just for you to be super clear. And if I give you 3 factorial, in mathematics what it means is that you're gonna take all the integers from 3 to 1 and multiply them. So 3 factorial, that will be equal to 3 times 2 times 1. So 3 factorial is equal to 6, okay? If you are here to evaluate, I don't know, again, 4 factorial. So you're gonna take 4 times 3 times 2 times 1, 4 times 3, so this is 6, this is 24, right? So 4 factorial, it will equal to 24. Things for you to pay attention to, 1 factorial is 1, and also 0 factorial is also 1, okay? So keep in mind these two guys. That's how you find the factorials of a number. So if you want to know in how many different arrangements can you have, in how many different ways you can organize a set of elements, like this case of the books, is the total number of elements factorial. In this specific case, how many elements do I have? 5 books, so this will be equal in 5 factorial. Applying the definition of factorial, this will be equal to 5 times 4 times 3 times 2 times 1. We perform the multiplication. This will be 26, so this will be 120. Meaning that if I have these books, what this answer is telling us is that there are 120 different forms to organize, so like 120 different arrangements, to organize 5 books in this specific case on a bookshelf, okay? I have all those options on a bookshelf. All right, now let's move to our next topic. Let me move myself a little bit here. And the other commonly question where content methods are going to be important are like in these ones, where we are given, like we have a group of elements, and from that total group of elements, we need to make subgroups. We need to select few of them. So there is always one important question that you need to ask, and is the order of selection important or not? Okay? So that is the model of questions. Let's write it down here. Is the order of selection important or not? That's what we need to analyze, okay? When is the order of selection important? That is what we're gonna start analyzing right now. What happens when the order is important? First, the order of selection is important. How do we know that? When it is important is because, I don't know, think of the code to unlock your phone, okay? Code to unlock your phone. So normally, typically, they're gonna be 4 digits. So you know that the order is important if, when you analyze, that if you enter the number 4, 3, 1, 2, or you take the same elements, so maybe 2, 3, 1, and 4, you need to ask, is this the same? I mean, maybe with this one I unlock the phone, maybe with this one no, but they are the same elements. Simply they are selected in different order. If that selecting in different order makes a difference in whatever scenario you're analyzing, so the order is important. If it is not a difference, it's for you either this order, 4, 3, 1, 2, or 2, 3, 1, 4, is exactly the same in the exercise that you're dealing with. That means that the order is not important. Okay? So here, if we're talking about unlocking a phone, so if you put the code 4, 3, 2, 1, or 3, or 2, 3, 1, 4, is different. One of them is going to unlock the phone, but the other one is not. So what do we do here? Whenever the order of selection is important, is what I call the lines method. So when I say the lines method is why. First, okay, what we would like to do is like to draw as many lines as elements we need to select, okay? Draw as many lines as elements we need to select. The second step will be analyze and write, the number of options that you have to choose that element. Okay, number of options to choose each element. And the third step, we just, after we have analyzed and we have our numbers, we simply multiply. Okay, so let's do this with an example. Let's go back again to this scenario, okay? Let's unlock, okay, the phone. In this case, we need to choose a 4-digit code, right? Normally, typically. We need to choose a 4-digit code. All right? That's it. So if we apply this in the step-by-step process that we define here, so the step number 1 is draw as many lines as elements we need to select. We need to select 4 digits, right? So in this case, I will draw 4 lines. For the first digit, for the second digit, for the third digit, and for the fourth digit, okay? Now, let's start analyzing how many, the step number 2, write the options you need to, that you have to select each element. So if I want to select this element, that is a digit, how many options do I have? I will have 10, right? Why 10? Because this first digit can be any number between 0 and 9 inclusive. Okay, the first digit I include could be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. How many options do I have to select the second digit? Now let's analyze this one. Oh, the same 10, right? Because my code can be 1111 or 0000. I can repeat the elements. For the third one, I hope that you understand already. I will have another 10. And for the fourth one, we have another 10. So we have 10 different options to select each digit on my 4-digit code. Third step, I have these numbers and I simply go ahead and multiply. So I will end up here 10,000. That means that there are 10,000 different codes I can create for a 4-digit code to unlock my phone, okay? Now pay attention here that I have 10, 10, 10, 10. Why? Because I can repeat the digit. My code can be 0, 0, 0, 0, so I can repeat the element. There might be a variation and we are to select a scenario where we need to select an element and it cannot be repeated. So what will be the case? For example, let's draw here quickly another example. I have 5 people, right? And I need to select a committee, okay, of 3. And let's say that that committee of 3 should be like, because I want to have the president, I want to have the vice president, and I want to have the treasurer, right? So let's go with the same process. I have 5 people total. Committee of 3. So how many do I need to select? 3. That means that I will go here with 3 lines, right? With 3 lines. Second step, write the number of options to choose each element. So the first element here will be the president. The second element is for me to select the vice president and then the treasurer. So if I select the president first, how many options do I have? I need to select one person out of how many? I have 5 people total. So either of those 5 people can be named the president. So here I have 5 options, right? Now, how many options do I have to select the vice president? As we already have selected one person for being the president, then ideally, right, the president should not be the same person serving as vice president. So here I only have 4 options to select from, right? Because I have 5 people, but from those 5, I already selected one that was the president. So I only have 4 people left from which I can select the vice president. Now for the treasury, I already have selected 2 people, so I don't have 5 options anymore. I only have 3 options left, and the treasury should be one out of those 3. So I only have 3 options for me to select the treasurer. Last step, we multiply. And this will be equal to, this is going to be 20, right? So this is going to be a total of 60 options. So what I'm saying here is that of a group of 5, and I need to select 3 people, I can have 60 different selections, 60 different ways of selecting those 3 people, okay? Now for you to be clear on here, what we are saying on these 60 is that maybe these 5 people, okay, were Pedro, right? And even there were John and Maria and Daniel and I don't know any other names, and Camila. Okay, so what we're saying is that if I have these 5 people, Pedro, John, Maria, Daniel, and Camila, my committee could have been formed by Pedro and John and Maria, or it could be Maria and Daniel and Camila, or Camila and John and Pedro, etc. Okay, this is what I'm counting. Those are the 60 different subgroups that I can make. All right. So when the order is important, we just go with the lines approach, and that's it. Here, the step by step. Now let's analyze what happens when the order of selection is not important. And remember what is the scenario of not being important. Okay. The selection of not being important is, let's create a scenario. I don't know. We're going on a trip, okay? And in the car. So let's say that we are in a bus, okay? And on the first seat, there's gonna be Anna. On the second seat, Jairo. On the third seat, Camila. They can sit in this order, Anna, Jairo, and Camila. But they could also have sat first Jairo, then Anna, then Camila, or they could have said Camila and Anna and then Jairo, etc. Now, for me, this scenario is not important. Why not? Because we three are in the same bus and we all will arrive to the destination at the same time. I don't care in which order do we sit. It's not important for me the order of selection. I just need to select three. As long as I have those three, we're cool, that I don't leave anybody behind. But I don't care how they sit in the bus, so I don't care about the selection. Whenever we have that approach, okay, or that the situation where the order in which I need to select the elements is not important, we have a little formulita. Okay, so this is my formula approach. It's a new, my formula approach. And the formula, the way I remember, I know that books likes to do it with n and k for some reason. The way I remember the formula is this one. I have the total number of elements, factorial, over the number of elements that I want to select, factorial, times the difference between these two guys. So the total minus what I want to select, everything factorial, okay? Check it out. This is gonna be our little formulita. The total number of elements that I have, factorial, want is the total number of elements I want to select, factorial, and then the difference. So, for example, we have these 10 people, okay? 10 people. From these 10 people, we need to choose, I don't know, let's say 4 maybe. Choose 4 to represent us, let's say, we can select 4 to represent the business, representatives, okay? We need to select 4 representatives for a conference. Again, I don't care the order in which I selected, as long as I select 4 and I send 4, we're okay. So if I have this scenario, of course, the question would be, you know, how it will be in the exams would be how many different groups or how many different selections can I have? Can I make selections? Can I have? That's gonna be it. So the order is not important. And again, being the order not important, we start analyzing this, and we have total, right? The formula total. How many people total do we have here? We have 10, so this thing will be 10 factorial, right? What we want, the number of elements I need to, or I want to select. In this case, we need to choose 4, meaning that this will be 4 factorial. And then the difference, that is the total minus what I want, everything factorial. So this will be 10 factorial over 4 factorial times 6 factorial. Now here, sometimes people get scared because, man, but 10 times 9 times 8 times 7, you know, try to find the factorial. But see what happens, and this is always very repetitive in the exams. You don't need to multiply all these numbers. At the end, they start canceling them out. Why? Let's express this in discrete form. 10 factorial will be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? Now, 4 factorial. 4 times 3 times 2 times 1. 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. Now check out that when you do that, check out what happens. I just start canceling these guys, right? The 1 can cancel with this one, this 2 goes with this one gets cancelled with this one, 4 with 4, 5 with 5, 6 with 6. The 1 is not really relevant. Let's keep simplifying. Here we have a 2 that I can simplify maybe with the 8. So this will become a 4, right? And the 3, maybe I can simplify it with this 9, and here I have a 3. And check that this 4, I can simplify the 4 with the 4. And after having made the simplification, check out what I have. I still have the 10, yes, I have the 10. I have a 3 here, times 3. I have a 4, times 4. I have a 7, times 7. And that's it. Everything down got cancelled, right? So if we do this number, this is going to be equal to what? This is going to be 7 times 4. So here, what do we have? Here we have 12, 120, and 120 times 7 it's 700 and it's 840, right? Let me do that again. 12, 120, 700, yeah, 100, 840. So what I was saying is that if I need to select 4 people out of 10, where the order is not important, I have a total of 140 different selections that I can make. All right, just applying the formula. Again, you see factors here, and these might seem big numbers, but at the end of the day, check out that they are not as big as what we think it is. Okay? I hope that this is clear.